When we talk about aerosols, most people imagine a can of deodorant, a bottle of perfume, or a can of spray paint. And it's true, those do all produce aerosols, but the definition is actually much broader. An aerosol is simply a group of solid particles or liquid droplets in a gas. With this definition, many more things are aerosols than we might initially think, and I bet you've come across one this morning. Whether it's the steam over a hot drink, clouds in the sky, an asthma inhaler, or someone coughing and sneezing, aerosols are all around us. With such a broad definition of what an aerosol is, it makes sense that they would have a wide variety of different types. One of the most common ways to categorize aerosols is by their size. Some of the largest aerosols are things like pollen from plants, sand and dust in desert storms, or the water droplets in mist and clouds. These can be up to 100 microns in diameter, that's a tenth of a millimetre, or about the width of a human hair. At their smallest, aerosols can be a few nanometers across, which is nearly a millionth of a millimetre. Aerosols that small can include airborne viruses, smoke from tobacco or fires, or pollution such as smog. Not all aerosol particles are the same shape. Droplets are spherical, but sand will be more cubic, and other shapes such as long fibres or complex branches are possible for other particles. To be able to compare the behaviours of aerosols, we can mathematically calculate an equivalent sphere diameter, which is how big a spherical particle would have to be to behave in the same way as the real particle. With so many different types of aerosols, from naturally occurring like clouds or viruses, to man-made like pollution or asthma inhalers, aerosol science is an incredibly broad topic, tying into all branches of science, from biology to engineering and everything in between. One of the big ways that aerosols have been in the news recently is through disease transmission, such as COVID-19. When we cough and sneeze, but also when just talking or breathing, we produce tiny liquid droplets from our mouths and noses. These can easily be seen on a cold day, but we produce them on warm days too. These droplets are not normally of concern, but if we're ill, then the viruses or bacteria that have made us ill can live in our mouths, noses, or throats and get caught up in the droplets that we breathe out, so we can accidentally spread them to other people. A key role of aerosol scientists who study the respiratory spread of diseases is to try and understand how these droplets spread, how far they can go, and how long they can survive in air. This all informs the guidance that the government gives out, such as wearing masks to limit how many droplets we can breathe out, or keeping 2 meters apart to minimize the number of droplets that can reach another person. Some aerosols present more of a risk to us than others do, depending on their size. Aerosols below 10 microns are called respirable aerosols, as they are small enough to be inhaled. Some aerosols, once inhaled, will stay in the lungs or airways where they can cause damage. Governments and regulatory bodies such as the EU and the World Health Organization have limits on how much respirable aerosol people should be exposed to. These limits apply to our general surroundings with a focus on pollution such as car exhaust fumes, industrial smog, or smoke. But not all aerosols are bad. Some are completely harmless or even incredibly helpful, such as medicines in inhalers, which can be used to treat lung conditions such as asthma, chronic obstructive pulmonary disease, or emphysema. Aerosols are also being widely used in industry to create new and cheaper materials and are especially good at producing fine powders or thin films. Thin films in particular are used in electronics, where they are the key to the structure and function of solar cells and transistors. The study of aerosols is diverse and important, both to understand more about them and their impact on us and our environment, but also to learn about how we can use them. To find out more about the different topics talked about in this video, have a look at the other videos in this series and consider higher education and research in aerosol science.